Hello everybody and welcome back. Root Beer here with more of the year 2000 Fermat paper. That's the grade 11 contest. And we're on to question number 20. It's the last one in part B. So what does question 20 say? Given that A plus 2B plus 3C plus 4D plus 5E is equal to K, and that we have this relationship, 5A is equal to 4B is equal to 3C is equal to 2D is equal to E, find the smallest positive integer value for k so that a, b, c, d, and e are all positive integers. Okay. So, we have a lot of variables, but they all have a relationship amongst one another. So I think the best thing to do is pick one of these values, and I don't know which. Maybe get everything in terms of A, or get everything in terms of E, or B, or C, or D. Okay, and one of those, perhaps all of them, we should be able to then substitute them into this equation and get k has to be some number divided by something. And in that way, we can sort of guess, well, what if k was 1? Could we have this, or this, or this? So that's sort of the idea. Alright, so I'm just going to pick one. I'm going to say, let's get everything in terms of e. Okay, we'll see where that gets us. So, we're told 5a is equal to 4b is equal to 3c is equal to 2b is equal to, 2d is equal to e. Now what did I say? I was going to get everything in terms of e. Well, e is going to be one copy of e. D, well, 2d is equal to e, so 1/2 of an e is equal to a d. C is going to be 1/3 of an e. B is 1/4 of an e. And A is going to be, well, 5a's is an e, so 1/5 of an e is an a. Now K is equal to A plus 2B plus 3C plus 4D plus 5E. So let's substitute everything in and get K in terms of E. So 1/5 E plus 2/4 E's plus 3/3 of an E plus 4/2 of an E plus 5 E's. Okay. So some things I can notice immediately. These 3 and the third will cancel out. We'll get another copy of E. We'll get 2 E's here. We'll get 1/2 of an E. Alright. So, what do we got here? So, 1/5 of an E plus 1/2 of an E. That's 5/10 plus 2/10. So that should be 7/10 of an E. Plus 1E plus 2E plus 5E. So it should be 8 7/10 of an E is equal to K, or another way of saying that is 87/10 of E is equal to K. Alright. Some other things I can notice right away, if these all have to be integers, A is going to have to be 1/5 of E, so E is going to be a multiple of 5. E's also got to be a multiple of 4 and a multiple of 3. So E is going to be at least 60, I think. So if we want to minimize K, we want to make E as small as possible. What does E have to be? Well, E really just needs to make sure that A, B, C, and D are integers. So we just need to have E be the smallest multiple of 1, 2, 3, 4, and 5. And that is 60, but let's see why. So 2 is 2 to the power of 1. 3 is 3 to the power of 1. 4 is 2 to the power 2, and of course 5 is 5 to the power 1. So we prime factored these numbers. So if we want the lowest common multiple, so we look at each prime in turn and find the highest exponent, and then we multiply them all together. So I see some 2's in here. The highest power of 2 is 2 squared. The highest power of 3 is 3 to the 1, and the highest power of 5 is 5 to the 1, and we have no other primes. When we do that, we get 60. Now 60 is divisible by 5, it's divisible by 4, 3, and 2, and it is the smallest number. K is smallest when E is smallest. And E equals 60 is the smallest it can be. So K is 87 over 10 times 60, which is just going to be 6 times 87, and that is 522. And for those of you who doubt it, A is going to be 5, or sorry, A is going to be 1/5 of E, so that's 12. B is going to be 15, C is going to be a third, and D is going to be 30. But that's neither here nor there. We're just verifying that they are in fact integers as we wanted. The next value E could be is 120, but obviously that will give you a larger value of K, and we want the smallest value of K. So, find the smallest positive integer value for K, so that A, B, C, and D are all positive integers. 522 does the trick. So, an answer of B. And that wraps up B part. Join me for the next 5 questions in the next 5 videos, and these should be the harder questions because it's part C on the Fermat. So we'll take a look at question number 21 in the very next video. I hope to see you there.